See how far we get.
Not far.
All right, 11.5. Products and quotients of radicals. Can y'all see okay in the back? Products and quotients of radicals. What are products?
Multiplication answers.
And quotients?
Dividing.
Dividing. Dividing. Excellent. Okay. So quotients and products. So y'all just took a quiz yesterday. Excuse me. We started radicals before spring break, along with the Pythagorean theorem that we did this week. Now we're going to finish the chapter, and yes, I do think we're going to finish it, stop after this. We'll see. With multiplying and dividing them. Okay, it's a lot of information in one section, which is why I said we might break it up into two parts. We'll see. Oh, I forgot to set the alarm. Hold on. I don't want to lose track, make y'all late for Spanish. Okay, got it. All right, so simplifying. This is important first before we get into multiplying and dividing. You got to learn how to simplify radicals. Step 1, you're going to do the factor tree, and you're going to list prime factors. Taylor, I sincerely hope you're taking detailed notes today. I'm very, 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 very serious. Step 2, you're going to circle groups of 2. In fact, Taylor, if you want, you can sit in Michaela's desk. Are you coming? All right. Step 3. Circled groups go on outside of radical sign. And multiplied if needed. Got about 4 pages of notes. Step 4, leftovers, see that's in quotes, go on the inside. So I'm going to underline outside, circle groups go on the outside of radical sign, leftovers go on the inside of radical sign. And multiplied if needed. All right, I'll let y'all catch up. Taylor, I've come to a stop sign. If you need to unbuckle your seatbelt and come move up, you can. I'm not driving at the moment. Your choice. So I'll let y'all catch up. Put your pencils down when you have written everything so that I know that you're done. Michael, please tell me you're taking detailed notes today. Good. You're going to need to. This is seriously uncharted territory for you guys. So and it's going to be a lot of information of different places. You know what I'm saying? So you're going to need to take detailed notes so that you can come back to this in case you need to. Okay, so when simplifying radicals, you're going to do the factor tree, which y'all have done. We're going to list the prime factors. Then we're going to circle the groups of 2. So y'all have done this before. Here, 3 and 4 is what's new to y'all. The circled groups go on the outside of the radical sign and multiply together if needed. The leftovers go on the inside of the radical sign and multiply if needed. So for example, I think from here on out, I just got a ton. I got like 4 pages of examples. So for example, if I said, what is the square root of 12? Okay, so let me back up. You do not need to write what I'm about to write. Up here, if I said, what's the square root of 4, what is it? 2. If I said, what's the square root of 16? 4. Okay. Those are called perfect squares. They're perfect because it's just one number multiplied together to get the radicand, the number under the radical sign, okay? Those are called perfect squares because 2 squared is 4. 4 squared is 16. Y'all get that, right? This is not. There's not one number that when multiplied gives you 12. So like when y'all are doing the Pythagorean theorem, remember the other day when y'all are doing that? And I told y'all to just leave it like this. And it said something about rounding it to the nearest tenth, They're saying use your calculators and find out what the square root of 12 is. And it's a decimal problem. It's a decimal answer. Okay, that's saying that you got a calculator with you that can do that, okay? Yes, I know we have phones and technology that can do this, but not always are we going to have that. That's why I said in your answers, you can leave it. If it's not a perfect square, just leave it. But I'm going to show you how to simplify it because you do need to know how to simplify it. All right, so step 1, do the factor tree. So your calculators would give you a decimal answer for this, okay? But I'm going to show you how to do, again, simplified. So please make sure you do this. What 2 numbers give me 12 when multiplied?
4 times 3.
All right, 4 times 3. 3 is prime. 4 is not. And that'd be 2 times 2. Everyone with me so far? Does everyone remember doing this? Okay, at any time, stop me with questions. I told you, we're not rushing through this today, okay? So please let me know if you have questions. All right, step 2 says circle groups. Oh yeah, list prime factors and then circle groups. So if you remember, we list the prime factors in order from least to greatest. Do y'all recall this? Now, step 2 says to circle your groups of 2. That's my only group. Now, and they don't mean the number 2. They mean your pairs. Y'all remember that, right? Okay, so you're circling your, I should say groups of pairs. That would make more sense. Not just the number 2. But y'all understand, I'm assuming. Taylor, you're taking notes? All right, good job. Okay, now number 3 says circled groups go on the outside of the radical sign and multiply if needed. Leftovers go on the inside. So just like we used to, I need to put this. List in order least to greatest. Least to greatest. That says order. Now, when we used to do the greatest common factor and stuff like that, did we move 2 2's over or just one? Just one. Okay, so only take one number from each circled. I don't see pencils moving, Taylor. And I mean not in the air. On your paper with words. Only take one number from each circled group.
What is that? Oh, I see. Okay.
All right. So step 3, circle groups go on the outside. So I'm going to put my radical sign. The circle group, and it says only take one number from each circle group. So I'd only take 1, 2, put it on the outside. 4 says leftover. So what's my leftover?
3.
There you go. 3 is my leftover. It goes on the inside. And there's my answer. 2 times the square root of 3. Write this down. Nice, neat notes means nice, neat grades.
So what would that be? 18.
There's no square root of 3.
Oh, it's...
You understand? So that is, all we're doing is simplifying the radical, okay? Now, you can still use your calculator. In fact, let me show you real quick. You don't need them. There's no way your calculator is going to simplify, and that's all I'm wanting. There's going to be times in your math life that you don't need to get the actual answer. All you're doing is simplifying, okay? So, for example, square root of 12. Here is my square root sign. It's yellow, so I press second, the yellow button, and this button. There's my square root. Or, yeah, the radical sign. 12. See the decimal? It's not going to get you the simplified version. And that's what we're learning today.
Wait, did it say 3?
4, 6, 4, blah, 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 blah.
3 was what's in the square root. Is that a coincidence?
Now, look here. Let's put this into our calculator. See if we get the same thing. That's 2 times the square root of 3. So I have 2, second, and then square root, or radical sign, 3. And we get the same thing. That's how you would enter it. But we're not doing that. We're learning to simplify. And yes, you have to know how to do this. Any questions so far? Aiden, since you just came in, when we're done, I can loan you this because all you've missed is up here, or you can watch the video and get it, okay? It won't take you a second to write all that down. I'll give it to you when we're done. All right, number 2, or example, another example. We're just going to keep doing examples. Let's simplify the square root of 125. All right. What 2 numbers when multiplied? Give me 125. First of all, what number can go into this just by looking at it? 5. You're correct. Because of this. We know it can't be 2. So I'm going to say 5. and it's prime. But 5 times what gives me 125? Think of quarters. See? 5 quarters give me $1.25. I love it when it works that way. I like quarters. I can wrap my head around money. Okay, this is not prime, so I'm going to keep going, and that one's going to be 5 times 5. All right, so that's part of step 1. The other part is to list your prime factors in order, and this time they're all 5s. Step 3, pairs. Circle my pairs. I only have 1 pair. And what's this? This is called the leftover.
In quotation.
That's, yeah, but just that's your leftover. Here's my radical sign. The circle pair goes where?
On the outside.
On the outside. And we only take 1 from the pair. And the leftover goes where?
On the inside.
And we're done. So the answer is 5 times the square root of 5. Y'all understand this? All right. Let's see. I'll take it up a notch. Look at that. See, last time I did this, I had to do like 1,000,000 examples. We're already on page 2. I can skip some. Let's do another one. What is the simplified version of the square root of 72? So step 1, we do our factor tree. Taylor, you writing this down? Okay, good boy. Look, I'm like that parent with all the kids. I used to carry around a ruler in my, I had a Suburban, and I always had a bunch of kids with me, you know, Zachary, Allie, sometimes I'd sit in the very back, and I had this big ruler thing, and so whenever they misbehaved when I was driving, I'd reach back and hit them with the ruler. So y'all are like in my bus, we're going for a ride through Radical World, and I've got my stick, and I don't care how far away, I will get y'all with my stick if y'all are not behaving.
Throws it like a sandals.
A what?
I said throws it like a sandal.
He's talking in
I know. I actually get that one. All right, so what 2 numbers?
36 and 2.
36 and 2. Good job. 2 is prime. What 2 numbers give me 36?
6 and 6.
6 and 6.
Ooh, 6 and 6. See, I knew if I tell a story, y'all all have this figured out. And then?
3 times 2.
Or whichever, yeah, okay.
I did.
It doesn't matter. We can do it different ways. But in the end, do we always have the same primes if we do it? Yes. So now we list them in order. 2 times 2. Remember how I used to cross out these to keep us from messing up? And y'all should have the same as me. All right, this time I have a few pairs. Here's a pair, and here's a pair. I have a pair of 2s and a pair of 3s. What's my leftover?
2.
Just this lone 2 right here. So remember, the circle go on the outside. So look at this. I'm going to take 1 from each pair, put it on the outside. And I write it 2 times 3. See, 1, 2, and 1, 3. And remember, we're multiplying. An even step right here, 3 and 4 says, and multiplied if needed. So if you have more than one number on the outside or inside, you're going to multiply them. And then this lone 2 here, this leftover, goes in the inside by itself. 2 times 3 is what?
6.
So it's 6 times square root of 2.
Wait.
Okay, I'll wait.
2 doesn't have a square root. Wouldn't it be 1?
No, 1 times 1 is not 2. That's okay. It's okay.
1 plus.
I get what you're thinking. Any questions so far? Man, y'all are doing really good. This is probably the best pre-algebra class I've ever had.
Well,
Maybe I'm just improving in my teaching over the years, and my students are getting it better.
I mean, you
Yeah.
said this is the best class I've ever had. I never memorized my times tables.
What?
Memorizing multiplication, you know what? It's not going to hurt you to not be able to do multiplication like this. It only helps with speed. That's it. The kid that can multiply and it takes them 5 minutes to do the same thing as someone that can do it like this, you got the same knowledge. It doesn't matter if you can do it like this or it takes you days. As long as you have the same knowledge, what does it matter, right? If you don't have it completely memorized, is that gonna hurt you in any way? No, it may slow you down, but you got the same knowledge. So just because someone can't memorize multiplication facts means absolutely nothing. All right, y'all got all that? All right, let's do another example. You are doing really good today. I always start my day off so good with y'all. Okay. So, square root of 240. Woo, that's kind of a big number. Here we go. 240. Factor tree. Gabby? Wait, what'd you say? Okay. That's right, because it ends in 0, so we know 10 goes in there. So she said 24 times 10. Very good. All right. What 2 numbers can give me 24?
6 and 4.
All right. We're going to 6 and 4. And then 10, we can do 2 times 5. Those are prime, so I'm going to circle them so we don't get confused. 6.
3 times 2.
Yeah, man. And those are prime. And then, of course, 4 is 2 times 2. Y'all have that? I'll let y'all write it down. Okay, now we list them in order from least to greatest, and remember to cross them out so we don't forget any. That eliminates those silly mistakes and ensures good grades. Now, before I move on, I'm going to make sure I got everything. 1, 2, 3, 4, 5, 6 circles. 1, 2, 3, 4, 5, 6 listings of prime factors. All right. Y'all have all this? Some of you, I think, have worked ahead and already solved the problem. So now I'm going to circle all my pairs. And then, so this time, what's my leftovers?
3 and 5.
That's right. This time I have 2 leftovers because I don't have pairs for them. So I'm going to write my radical sign. These pairs go on the outside, and that would be 2 times 2. Do y'all see that? And then my 2 leftovers go on the inside. That would be 3 times 5. And just like in steps 3 and 4, you multiply. 2 times 2 is 4. 3 times 5 is 15. And there's my answer. Y'all get this?
Yes.
Impressive. Any questions? Don't y'all wish this was all? But it's not.
Can we do
Are you kidding? I still have products and quotients to do.
so?
All right, y'all.
Wait, which one is harder?
Which one do you think will Which one do you prefer, long multiplication?
Here's where things get kind of crazy. Are y'all ready? All right. Here's where you need to buckle up. Make sure you're in tights. All right. Here we go. We're going to talk about products. That was just like greasy, yeah, warm up. This is when you're multiplying. And I'm just going to do one example after another. Let's start easy. Let's say I have the square root of 7 times the square root of 3. Notice there's no dot or anything. They're just two square roots side by side. This is how you solve it. Put the 7, you're multiplying, right? If there's no operation sign, we know that you're multiplying. So then we do 7 times 3 under the radical sign. What is 7 times 3?
21.
Can this be simplified any further?
Yes.
Really? Let's do a factor tree. What two numbers give me 21? Those are prime. So if I list them, do I have any pairs?
Wait, that's the same thing as what you started with.
Okay, but I'm saying once you get your answer, you got to check to see if it needs to be simplified. Okay? And we did the factor tree. Do I have any pairs?
No.
So it'd go right back underneath this, right? So you're, like you said, it's going to be the same thing. So this is your answer. That's all you have to do.
That's easy.
Oh, just wait.
Well, that's fun. I don't remember seeing it.
It's like we say.
It gives us number
we're okay.
2,583
Like the
times
like what you assign us, and we just really fail everything.
Or about 24 trillion times 4,500.
1 centillion. No,
All right.
1.58933334.
Do y'all have this down?
Yes.
All right, let's do another one. This one's a little different. Let's say I have the square root of 14 times the square root of 21. All right, first of all, if you look back, these are prime numbers, right? These are not. So what I'm going to do is I'm going to factor them out first. What two numbers give me 14?
7 times 2.
And those are prime. What two numbers give me 21? Okay, now just like before, I'm going to write down my factors. Okay, I'm going to write down my factors. And I have, in order, 2 times 3 times 7 times 7. I'm going to do them all. So I'm combining them. Do you see that? And in fact, I'm going to say combine prime factors. What are my pairs?
7 and 7.
What are my leftovers?
2 and 3.
So the 7 goes where?
On the outside.
I just do one of them. Michael, you writing all this down? I'm going to be checking. The leftovers go on the inside. 2 times 3. So my answer is 7 times the square root of 6. That's still not too bad, right? It's thunder. Y'all hear that?
Right, doctor.
I'm just playing.
I wish it was.
I know.
Because then it would rain and then it would flood.
It
and
was
then we
raining
never
Alright,
get
shh.
school.
No, I'll come pick you up. I'll help
No.
you can get through the hot
No.
water.
No.
It was raining this morning. It
All
might
right.
still be raining.
Alright, it was misting. I wouldn't even call that rain. It was just getting my car muddy. Okay. Any questions about this?
No, can we do the division
The what?
That
now? Can we
is.
do the division
No, we're gonna keep doing some multiplication.
now? Are there gonna be any negatives?
No.
Did you get a negative?
2 times the square root of 54. This time there's a little dot there, meaning what?
Multiply.
Very good. Multiplication. Times 3 times square root of 15. Okay, so notice this one's different. Here I just have 2 radical signs with, the radicand underneath. That's it. Here I've got a 2 and a 3 on the outside. So watch what I do. Because of this multiplication, I'm going to multiply the 2 and the 3. What do you get?
6.
Thank you for people paying attention. 2 times 3 is 6. Times the square root of 54 times 15. See what I did there? What part do you not understand?
Why would you do that? Or why do you need to multiply the 2 and 3?
Because I'm multiplying, and they're on the outside.
Okay.
So now we're going to work on the radicands, the things that are inside. I'm going to do my factor tree over here. What 2 numbers when multiplied? Give me 54. 9 times what?
6.
And then I have 3 times 3. And then 2 times 3. Any questions? And then over here, we can just do 3 times 5. Now, just like up here, I'm going to list all my prime factors in order from least to greatest for all numbers. So I've got 2 times 3 times 3 times 3 times 3 times 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so I need to circle what?
The
Pairs. Yeah, go ahead, Whit.
the 2 pairs of the 3.
There you go. And what are my leftovers, Izzy? Very good, 2 and 5. All right, my pairs. Now keep in mind, did I already have the 6 on the outside? Y'all see this 6 on the outside? I'm going to bring it down again. Y'all see that? The 6 is on the outside from the 2 times 3. I'm going to bring it down, but I also have to bring my pairs to the outside. Yes? Izzy? Is she leaving? No. Okay. 3 times 3. And I'm multiplying that with the 6. Hurry, Izzy. Do y'all see that before I move on? Does everyone see that? Okay, look. See the 6? We started with 2 times 3. That's on the outside, right? I'm going to continue with that. Remember, like over here, all the circle pairs go on the outside. So I have a circle pair and a circle pair. It's also going on the outside. And remember, we have to multiply everything. So do you see that now? Okay. My leftovers go on the inside. 2 times 5. And then I multiply everything together. Does everyone see that? You see it, Gabby? You see it, Michael? Joanne? Cecilia? Aiden?
Yeah.
Whit?
Yes,
Taylor? All right. 3 times 3 is what?
9.
Times 6?
54.
Wait, what?
And then 2 times 5 is?
10.
And there's your answer.
It's not
No. It's just time consuming.
that.
Any questions? All right. Whoops. Izzy, hurry up and write this real quick. So Izzy, the 6 that was already on the outside, we bring it down and still. See, it's on the outside already? You see that? So I bring that down, and then just like we've been doing, the circle pairs we put on the outside, and we're multiplying all of them together. My leftovers, my 2 leftovers go on the inside. So multiply all that, you get 54. Multiply the inside, you get 10. You done? Man, you must have ran. Let's do another example. All right. Square root of 5 times square root of 10. Whoops, sorry. This is prime, this is not. So I'm going to go over here. This is just 5, so it's already prime. This one's going to be 2 times 5. So if I write my prime factors together, 2 times 5 times 5. Y'all see where I'm at? Circle my pair. There's my leftover. Five goes on the outside and the 2 on the inside. So my answer is 5 times square root of 2. Any questions? Let's see here. All right, I'm going to do one more multiplication one, then we'll start quotients. Y'all have this down? All right, here we go. Last multiplication one. Square root of 6 times square root of 42. All right, do my factor tree. This one is 2 times 3. What 2 numbers when multiplied give me 42?
6 and
21
7.
times 21. 21 times 1. Wait,
6
2.
and 7.
21 times 1.
I'm going to go with
Yes.
6 and 7. Y'all can do 21. Y'all can do 21 too. It doesn't matter. It does not matter.
21 times 1.
And then 2 times 3. Stop. And then we list out in order from least to greatest. I have 1, 2, 3, 4, 5 circled and 1, 2, 3, 4, 5 listed. I'm going to circle my pairs, and there's my leftover.
Will there be one where they're all pairs?
If everything goes on the outside, then that's your number. It won't even have a radical sign.
Oh.
So then I take my pairs, put them on the outside, and I have 2 times 3. And then my little leftover goes right here, 7. So my answer is 6 times the square root of 7. Any questions?
Earlier we had 7 times the square root of 6.
Everyone got it? Michael, you still writing? Okay. Put your pencils down when you're done so I know you've finished. You got it? Okay. Let's talk about quotients. All right. Start giving you examples. Let's say your problem looks like this. 25 divided by 4, and that's the square root of 25 divided by 4. Okay, question. Can 25 be divided by 4 evenly? No. So we're going to separate them out. Is this a perfect square?
It is.
Is this a perfect square?
It is.
What's the square root of 25, Emily? Michael, what's the square root of 4?
2.
There's your answer.
It's that easy?
Yes.
Well, except the ones that don't.
Yes. You do not have to simplify.
How do you simplify?
5 divided by 2. You either can put it in a mixed number because that's an improper fraction. You can put, now if you want to because you've been trained and that may bug you, then go ahead and put it into a mixed number or a decimal. That's perfectly fine.
What if, oh, you already said this.
All right. Hold on just a second. Okay. How about square root of 45 over the square root of 5? Are these perfect squares?
No.
And it has to be both of them. Even if this was a perfect, then but this wasn't, you can't do it, really. So what we're going to do, okay, so those aren't perfect squares. So we're going backwards from here. Whoops, equals 45 divided by 5. Can we do 45 divided by 5? What is that, Joanne? 45 divided by 5? Mm-hmm. Square root of 9. Is that a perfect square now? Cecilia, what would that be?
3.
And there's your answer. So the division one is a little bit different than multiplying because you got to play with it a little bit. You got to kind of sit back and look at it and say, okay, what are they perfect squares? What do I need to do? Blah, 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 blah. Y'all see that? All right, let's do some more.
What if they aren't a perfect square and they can't divide evenly?
Like this?
No, ma'am. Like if isn't there a number that's not a perfect square and doesn't divide evenly?
Good question. Let's see.
Is that not what the first example is?
No.
Well, these were, he said they weren't perfect squares. These are perfect squares.
And you can divide.
No, I mean, it's either going to be one way or the other.
Okay.
Tomorrow we'll do all the examples in the book. Okay. In fact, we're almost finished with these notes today, and then I'm going to, then we'll stop, and then tomorrow we'll do the examples in the book, and then I'll assign homework tomorrow. So y'all have no math homework today. Okay, so let's do the square root of 18 divided by the square root of 9. Are these perfect squares? No.
Oh, one, but
But, okay, so 9's a perfect square, but it's 18. No, so we can't do like we did on the very first one. These are perfect squares, so it worked out, but these aren't. So I'm going to do 18 divided by 9. 18 divided by 9 is?
2.
And it's still under the radical sign. Michael, are you writing all this down? Exactly. So notice, just because 18 can be divided by 2, we don't just get rid of the radical sign. It is still under that radical sign. Now, can I simplify this?
No.
This is not a perfect square, and it's just 2 times 1, so nothing can come out. So this is your answer. This is as far as I can go. See, we got to here on this one, but that's a perfect square, so we're able to get to here. This one can't come out, so this is it.
Is this what Whit was talking about?
No, Whit was saying if it can't be divided and it's not a perfect square. If it can't be divided and then we would just try to simplify it as much as we can, but I don't think y'all got any problems like that. Let's do another. 8, square root of 8 divided by square root of 2. Are these perfect squares? Taylor, you writing this down? So we're going to do it again. Izzy, what's 8 divided by 2? So it's going to be the square root of 4. Emily, is that a perfect square? So what's the square root of 4? There's your answer. See the difference between the two? This could not go any further. Had to stay in the radical. This, though, we could continue simplifying. I got 3 more, and then we're done for the day. Square root of 98 divided by square root of 2. Are either one of these perfect?
No.
Nope. And 98 can be divided by 2. Aiden, what's 98 divided by 2? Okay. Huh?
49.
Very good. And we're still under the radical sign. So let's see. Joanne, is that a perfect square? What's the square root of 49?
7.
Perfect. Any questions about this so far? I got 2 more. Michael, square root of 81 divided by the square root of 16.
They're both
Very good. They're both perfect squares. I'm writing that down. Both of them are. That says both. All right, so Michael, what's the square root of 81?
9.
And what's the square root of 16? 9 cannot be divided by 4 evenly, so you can leave it, or you can go ahead and write it as a mixed number or decimal. Any questions? Y'all think you got this?
Okay.
Yeah, let's get released.
No? Okay, so I'm gonna stop here.